Watch the ride.
Hey everybody, you might remember in the past I made a video called How Does a Motorcycle Engine Work? I've done another one called How Does a Motorcycle Gearbox Work? Another one, How Does a Car Gearbox Work? And I'm doing another video a bit like those, but this time talking about cooling and the different methods of cooling that are used on engines. Now this will apply to all engines really, but I'm going to talk specifically about motorcycles because I have the examples in motorcycle form in front of me. So then comes the basic question, what is cooling and why do you need it? Well, cooling is just, cooling the engine down, because if an engine runs hot, it increases the chances of wear. It also means you can't push the engine as hard because obviously if it's getting up to a temperature that's going to start causing damage, you can't run it any harder than that. So if you cool the engine itself, you can run it harder, faster, and it won't get nearly as much wear on the bore and the other parts. So it will last longer and be more reliable. There's basically three methods of cooling: air cooling, water cooling, and oil cooling. So let's start with the basic one, which is the old school method, air cooling, and it's also what's used on most, if not a lot, of 125s and things like that. You do get some bigger bikes that still air cool, but not so many these days. This is the cylinder head off of a 125cc motorcycle, and this is an air-cooled engine. You'll know it's air-cooled because it's got fins like this, although don't be fooled because some companies will water-cool an engine and put fins on it to make it look like it's air-cooled even though it's not. But basically the idea of these fins, which continue down the bore, the next section down, like this, which is the actual piston bore, it's not from, these aren't from the same bike, that also has the fins on it. And basically each one is a channel for air to flow through. You've got more surface area by having the fins. Increased surface area means you can get rid of more heat, and then the air that passes over the engine cools it. Now for a small engine, 125s and things like that, this is absolutely adequate. But when you start getting bigger than this, then you need to go into either oil cooling or water cooling. Now I don't have an oil-cooled example here, but basically the way that works is that the actual oil that's inside the engine is passed up through a radiator, the air goes through it, takes heat out of it, and the engine oil is returned. So it's just cooling the engine oil itself to help keep the internals cooler. Normally that's quite a small little radiator, but it's not such a common way of cooling an engine because it's not nearly as efficient as something like this. Now this has been donated to me by Big Pezza, one of my subscribers, an absolute legend. He's given me this. I'm going to be doing a strip down video of like tearing the whole thing down because I'm going to be using it for my metal art business. But I thought why not show you some things as we take it apart. Now this is an Aprilia a 650 single cylinder engine, and it comes from an Aprilia, how do you pronounce that? I don't know. But anyway, it's also the same engine that's used in some BMW 650s. But this is a water-cooled engine. Now, I don't have the radiator here, so you're just going to have to imagine that. But let's just show you how this works, because this is super simple. Okay, so here's the bore off a DLZ 400 SM, which is another water-cooled engine. And as you can see, you've got 4 bolt holes that hold it together, but then you've got these channels in between that go around the bore, and basically these get flooded with water. The water helps take the heat away, and it goes into the radiator, and that's where it dumps into the atmosphere, as it were. So just imagine that inside the engine, you've got these little channels that are running through it, and when you pump water through them, it all passes through. These hoses here, this inlet, this outlet, and the pump is all the water cooling system is, and then as I say, it's got these channels running throughout the head. So cold water obviously sinks and warm water rises because the density difference. Cold water is more dense. So your inlet is going to be at the bottom, because when you cool the water in the radiator, as the air flows through it and takes the heat away, the cool water will naturally go down and the hot water will keep towards the top. So your inlet's at the bottom, and it comes up through this water pump, and then it goes up through the engine, where this appears to go onto the jacket, the water jacket, as that's what this is called by the way, the water jacket, and this one appears to cause something at the top of the engine, so I assume that's 2 feet. Once it's gone through the engine, it then comes up and out through the top, through this hose, into the radiator. So hot water comes out here into the radiator, gets cooled by the air flowing through it, goes in through here, gets pumped back through the engine, which then picks up more heat, and then it comes pumped back out the top and goes round and round and round and round. And that's basically it. It just, the more surface area you can have in here, the more heat you can get rid of, and the bigger that the radiator is, it also affects how much you can cool the water down. And that's all there really is to it. The important thing to know though is that the water system, if you live in a country which gets, well, you use coolant because it's supposed to increase the efficiency of getting the heat away from the engine rather than just straight water. It also prevents corrosion, but the reason you also use it is it's an antifreeze, because if you can imagine, you have pure water in there and it gets freezing cold, the pressure inside of the engine where it freezes, where ice expands, can do damage, and ice has got an enormous amount of power when it freezes, so that's why you have to use coolant. Thank you for watching. Don't forget to leave a like if you found this video useful. Oh, and if you want to see this thing being stripped down, I've got a video on that coming soon. This channel is made possible by the support of the audience. Please check out the links in the description and all the different ways you can help support the channel. Any help is greatly appreciated.